Alright, today we are doing 11.3 Wheel of Fortune theme. Sum and difference identities. Alright, Wheel of Fortune theme just because I came across this and I don't know, this is a typical math mistake on Wheel of Fortune. Going too fast and making simple mistakes. And this guy, I'm going to show you one clip of one guy. And he is amazing because he is the king of simple mistakes. We all make them, but he is definitely the king of them. Alright? So let's talk a little bit about this. First of all, let's take a look at this. Is the sine of 45 plus 30, if I add those together, is that the same thing as saying the sine of 45 plus the sine of 30? Well, there's an easy way to find out. Let's go to our calculator. Let's make sure we're in degrees over here. So the first thing I want to find out is what is the sum of, well, 45 and 30 is 75. So what is the sine of 75? Alright, the sine of 75 is 0.9659. Alright, so now I want to find out what is the sine of 45 plus the sine of 30. And when you do that, you find out, boom, bada bing, they are definitely not the same thing. Alright? A little close, yeah, for sure a little close, but not the same thing. So it makes you wonder, why? Why, Brust? Why? Why is it so? Well, actually, here's Mr. Brust's explanation of this, and it's going to get into a very in-depth process here. Now, here's the deal. Just sit back, relax, and watch this proof. He's going to give you a proof of why this is not true. Alright, and then he's going to lead into what is true. Alright, again, don't feel the need to copy this down in your notes. I didn't even leave a spot for it in your notes to copy it down. Just sit back, watch Mr. Brust, try and stay awake, and it'll lead us into our next thing.
So my goal is to prove what happens when I subtract or add two angles. So I'm going to start off with subtracting an angle. So let's start off with this blue angle here, and I'm going to say this angle from here to here is alpha. So I've got alpha right there. And then in red, I'm going to draw another angle. I'm going to call this one beta. So this is beta, and the other angle in blue was alpha. So that's great. So what I want to do is subtract these two lines. If I subtract the distance, I can find the distance between alpha and beta. So I'm looking for that distance. So ideally, if I want to make up numbers, if you're more of a concrete person, this first angle could be like 140 degrees. And then I want to subtract another angle from it. Maybe I'm subtracting 120 degrees. Obviously, what comes up? 20 degrees. So if I subtract these, then I get a new distance over here. That would be like my 20 degrees. So what is this angle? This angle is actually alpha minus beta is that angle. And again, the distance between this and 0 should be the exact same. It's this distance. We're subtracting. We're looking for a distance. So that's the basis of this whole proof. You're subtracting two angles, and really that's the gist of this. If you understand what we're doing, we're subtracting two angles. What we're going to look for is finding exact values now. So here is the proof. Get ready. This is fantastic. All right, let's start with the coordinates of this. This point right here, the xy coordinates. So I'm looking for these coordinates. Well, I can use my trig function. X is cosine, so that is really the cosine of alpha, comma, the sine of alpha. So those are my coordinates. Those are my xy coordinates for that angle right there. How about for beta? Same thing. If I want to find this point right here, the x value is cosine beta. The y value is sine beta. So it's depending on the angle, if I type it in my calculator, that'll tell me the number there. The one that looks weird though is this one. This angle is actually alpha minus beta. So what are the coordinates of this point right here? Well, you guessed it. It's the cosine of alpha minus beta, comma, the sine of alpha minus beta. So it looks intense, but that's our ultimate goal. We're trying to prove that this is the identity. What happens when I subtract them? So all we're going to do is show that this green line over here is congruent to this green line over here. So if we're going to do that, how are we going to show that? Well, we are going to use the distance formula. Remember the distance formula? Distance is just Pythagorean theorem. We're going to subtract our x's and square them. Then we're going to subtract our y's and square them. So if we do that, some people like to put little numbers here. If we like to do that, that's why I have these coordinates. So I'm going to subtract blue and red to get this distance, and I'm going to subtract black. And what is this point right here? Well, this point right here is over 1 up 0. So that one should be easier. Let's start with blue and red. Let's go for it. Going for the glory here. So let's do distance formula of Let's see, it's going to be the square root, and it's going to take some room here. I'm going to take my x value, so cosine alpha minus cosine beta. So cosine alpha minus cosine beta, square it, plus I'm going to do my y values. We're going to be sine. So sine alpha minus sine beta. Oh, this is so fun. I love it. So that's the distance between those two. Can we simplify this? Sure, we can FOIL this out a little bit. I'll change colors here. But we can FOIL this out. It's going to be what? Cosine squared alpha, and I may have to slide that over. I think this is going to take some room. Cosine squared minus cosine alpha beta. Then I'm going to have another minus. The inside terms, I actually get two of them, minus cosine alpha beta. So it's a difference of squares here, so I get 2 in the middle. And then my last one, cosine times cosine, was going to give me the plus cosine squared beta. Holy cow, that's the first part of this. Let's slide it over. I'm going to need more room, I think. Alright, so keep this rolling. What's the second part? Well, I'm going to add, same thing here. I'm going to get sine squared when I FOIL it out. Sine alpha times sine beta, and I'm going to have 2 of them, so I'm going to have 2 sine alpha betas, or 2 sine alpha, 2 sine beta. Then do the last term, it'll be plus sine squared beta. So that is just FOIL property right there. What's cool about this, though, is anything good happen from this? I hope so, because that's a mess, and I don't want to do much more. Check this out. I have a cosine squared here, and a plus sine squared here. What happens when I combine these two together? It's a property, yeah? Cosine squared plus sine squared is what? It's 1. Awesome. And it's alpha. They're both alpha. But check this out. Cosine squared beta, sine squared beta, what happens with these guys? They're also equal to 1. So really, if I add those together, I'm going to get what? 1 plus 1? 2. So that is actually 2. Unfortunately, that's as far as I can simplify it. This cosine alpha, cosine beta just comes on down, and then minus that 2 sine alpha sine beta. Fantastic. And really, technically, this is a distance, and I'm square rooting it all. So that's as far as I can simplify the first part. That is this line up here. So I just found, let's say, D1. That is the first distance. Let's find D2. I love it. This one is going to be based off of this point right here. So D2 is going to start with, and I'm going to give myself lots of room for D2. Here's my x value, here's my y value. So it's going to be cosine of alpha minus beta minus the x value of that. That's just going to be 1. And then I'm going to square it. Plus, I'm going to do what? Sine of alpha minus beta minus the y value of this point. I'm finding this D2 right here. Here's D2. So I'm finding that, and that's going to be minus 0. And I'm going to square that. Fantastic. So again, I got to do a little more foiling for D2. Let's FOIL this up. I'm going to end up with cosine squared alpha minus beta. Distribute it there. I'm going to get minus 1 cosine alpha minus beta. If I do this one, then I'm going to get minus 1. So, this is another perfect square. I'm just going to get 2 of these. And then I'm going to go plus 1 at the end. Negative times a negative. So if you want to expand that out and multiply it, feel free, but I'm just foiling it. This one foils great because that's just 0, so I'm just going to end up with sine squared alpha minus beta. Holy cow, look at this screen. I love it. So you can call your parents over and be like, hey, look what we're doing in math today. But this will look better. It'll get better here in a second. We're going to need some more room, though. Okay, so got myself a little bit more room there. So again, this is still square root of all this in a distance. Does anything cancel in there? Did anything good happen at all? Actually, something does happen, doesn't it? Check this out. We've got cosine squared plus sine squared. They're the same angle, just like it's 20. It's the alpha minus the beta. So these are Pythagorean identity. Those equal 1, and I already have a 1 in there. So check this out. I've got 2 minus 2 cosine alpha minus beta. Fantastic. And that's distance 2. And it's the square root of that. So we're doing great here. Very good. So we've got D1, D2. What I'm going to do is I'm going to set distance 1 equal to distance 2. That's our whole goal, to show they're the same. And I'm going to go ahead and square them both. They're both square roots, so I'm going to square both sides. So if I can do that in one lump sum, I think that'll help me out here. So I'm going to bring down, let's bring D2 on the left. I've got 2 minus 2 cosine alpha minus beta. And this is my whole goal. I'm looking for a difference identity. I want to get cosine alpha minus beta by itself. On the right side, I'm going to have 2 minus 2 cosine alpha cosine beta minus 2 sine alpha sine beta. Still barely fits, so I'm just bringing this down as my other distance. What's good about this? I see a lot of 2's in there, so that seems like it's pretty cool. So hopefully I can do something with my 2's. In fact, I can. If I subtract them from both sides, right off the bat, what's going to happen? Minus 2, minus 2. These guys are just gone. Then what else am I going to do? Well, this is negative 2 left over. I'm going to go ahead and, do we need more room here? I'm going to divide that by negative 2. Whatever I do to one side, I got to do it to the other. Divide that by negative 2. So these will cancel. Here's my final identity. You could have fast forwarded to this point. Cosine alpha minus beta. What do you get when I divide this by negative 2 and divide that by negative 2? I'm going to get cosine alpha, cosine beta, minus sine, not minus, plus, negative divided by negative is plus, sine alpha, sine beta. That is as far as we can go. That is the identity. That is amazing. Holy cow.
So that was great. Thanks a lot, Mr. Brust. He led it to a lot of these things, all right? He didn't give us all these. He gave us one of them. But it's true for all. We could go through the same process and come up with all of these. It would be really long and boring, and I'm sure you don't care. But if you do, again, go over to Ramstein High School, find Mr. Bean. You should be able to find him. He's the skinniest guy over there. He's got a big smile on his face, and he's just as nice as can be. Ask him, hey, can you teach me on the board? And he'll go over to the board, and he'll show you a long proof. If you need a good nap, I suggest going over there after school, giving him 30 minutes, and then going home. You'll sleep like a baby. All right, anyway, these are our new identities. If we add two angles together and we're doing the sine, it's sine times cosine, and I keep whatever I was. If I'm adding, I add sine and cosine. I switch the angles. If I subtract, I keep the subtraction. Over here, notice when we do the cosine one, let's do a cosine one right now. When we do a cosine one, what's going to end up happening is we're going to end up switching the signs. When it's cosine of alpha plus or minus beta, and then it becomes minus or plus beta, that means you switch whatever you originally had, all right? So let's do the cosine of 15. Well, the biggest trick to this, well, is finding what adds up to 15 or subtracts to 15. I know that that is 60, so we're going to do the cosine of 60 minus the cosine of 45. So that's our 2. So we're going to do cosine 60 minus 45, all right? Now, a lot of times there's a lot of different ways to do these and get to that number of 15. This is just one way. So let's do our cosine formula. So I have cosine of the first angle, so cosine of 60 times cosine of the second angle. All right, now it says if I am subtracting, I'm on the bottom, I actually am going to add. See, if I'm on the bottom, I'm on the bottom here, so I'm going to add these two together. So I'm going to do the sine of 60 and the sine of 45. All right, that's plugging it into the formula. Now we have to look it up. We have to know that cosine of 60 is 1 over 2, 1/2. The cosine of 45 is radical 2 over 2. The sine of 60 is radical 3 over 2. And the sine of 45 is radical 2 over 2. Then we just have some math. 1/2 times radical 2 over 2 is radical 2 over 4. Radical 3 times radical 2 is radical 6 over 4. And we have a common denominator. So I'm going to put radical 2 plus radical 6 over 4. All right, and there you have it. That is the exact value of cosine of 15 using the cosine difference identity. All right, strange looking answer for sure. All right, there are going to be a lot of these because you think about it, you have half, radical 2 over 2, radical 3 over 2. A lot of them are very similar, so they're going to look a lot alike. Let's go over here to the sine. Sine of 105. Well, there's a lot of different ways I could do this. I could do 150. That's not 150. 150 minus 45. That would definitely get me there, right? But I'm going to do a different one. I'm going to do sine of 60 plus 45. All right? 60 plus 45 is 105. Let's go to our sine formula. Now notice if I'm adding, I stay adding. All right, so I'm going to do the sine of the first angle, which is 60, times the cosine of the first angle, which is 45, plus, now I'm going to do sine of the second angle, 45, and cosine of the first angle. All right, sine, cosine, we just switch the angles. So sine of 60 is radical 3 over 2 times cosine of 45 is radical 2 over 2, plus sine of 45, radical 2 over 2, times cosine of 60, 1 over 2. So, simplify this, we get radical 6 over 4 plus radical 2 over 4, which is radical 6 plus radical 2 over 4. If you notice, same answer. Now, that's just a quinky-dinky coincidence, all right? It's not going to happen every time, but like I said, a lot of these come out the same, all right? There's only so many ways you can add 45, 30, 60. There's only so many ways you can add those up and get something, all right? So let's go to our first clip of this gem of a champion on Wheel of Fortune. Watch this guy. Now, the first thing you have to understand is the very first thing he picks up is $1 million thing. So if he gets the puzzle right, all he has to do is get the puzzle right, he gets $1 million, all right? Watch what happens.
Pick that up, turn it over, lay it down right over that London trip down there. 650.
Why?
There's a Y. 500.
G.
1G. 700.
C.
Yeah, there are 2 C's. Well. Wow. Okay.
Nice solve.
Oh, well, that'd be a good idea, yeah.
Mythological hero Achilles.
You can't accept that.
Okay.
Shelby.
I'll solve.
Yeah.
Mythological hero Achilles.
Yeah, that's it.
I mean, that's pretty funny. Like, if you go to college, you think you know who Achilles was. You know, you think you would have run across that. Maybe not. I guess not, and that's just unfortunate. All right, so now we have a tangent one. We want to get to 11 pi over 12. All right, now these can be tricky because they're fractions. No one likes fractions. We need to remember, though, that we need two things that add up to 12, and it's got to be 11. You just don't want to randomly have numbers over here because one of the things you want to think about is our angles are in terms of over 6, over 4, or over 3, right? So, I mean, I could obviously put 1 and 10, but I don't have a special, 90 degree, it's not in the unit circle for pi over 12, in other words. So I need one that's an odd and one that's an even. Well, I'm going to go with 9 pi over 12, and I'm going to go with 2 pi over 12. All right, now the reason I do that is because 9 plus 2 is 11. Obvious reason, right? The second reason I do that is because now I can reduce these down, and this is in fact going to be the tangent of 3 pi over 12, I reduce that, plus pi over 6. All right, and those are ones we know. So let's use our formula. So I'm going to start with plus, so I'm on the top here. Now, on the top, I do what it says, but now on the bottom, it switches. So we have the tangent of 3 pi over 4, 3 pi over 4, plus tangent of pi over 6. All right, I'm going to divide that by 1. Now I switch it to minus tangent of 3 pi over 4 times tangent of pi over 6. All right. At this point, I'm going to plug in my value, so I know that the tangent of 3 pi over 4 is -1. The tangent of pi over 6 is radical 3 over 3. All right. On the bottom, I have 1 minus, so again, tangent of 3 pi over 4 is -1 times tangent of pi over 6 is radical 3 over 3. And I forgot to put my 3 here. Way to go, Solomon. All right, so let's do a little simplifying. So we know this is -1 plus radical 3 over 3 divided by, that's 1, that's plus radical 3 over 3. All right. Here, this is a trick Bruss taught me. I'm going to multiply by 3 over 3. So -1 times 3, I'm going to come down here. -1 times 3 gives me -3. Radical 3 over 3 times 3, these cancel, so I get radical 3. So plus radical 3. Divide that on the bottom. 3 times 1 is 3. Plus radical 3, these 3 cancels, that's radical 3. So very similar. Now, it depends on your teacher. Some of your teachers are going to be very okay with this, all right? I think you're better than that. I'm going to multiply by the conjugate because we do not like radicals in the denominator. So I'm going to multiply by the conjugate. 3 minus radical 3 on top and bottom. All right? So let's see what we get. Negative 3 times 3 is negative 9 plus 3 radical 3. Radical 3 plus 3 radical 3 again. And then radical 3 times negative radical 3 is just minus 3. All of that over. Now I know the middle is going to cancel, so I'm just going to do the first times the last. 3 times 3 is 9, and radical 3 times negative radical 3 is minus 3. I know the middle cancels because I'm multiplying by the conjugate. I'm doing it to get rid of the radicals, all right? So negative 9 minus 3 is negative 12. 3 radical 3 plus 3 radical 3 is 6 radical 3. All right, all that over 9 minus 3 is 6. All right, we can reduce, we can take a factor of 6 out, so that's going to be negative 2 plus radical 3. All right, quite a bit of algebra there, but the pre-calculus part is this initial part that we have to worry about, all right? Let's see what our guy up to on a Wheel of Fortune now.
Wow.
L.
There's an L. Pick it up. You got both halves. So, 450.
D.
Yeah, there's a D. Ah. 300.
C.
Can I
Shelby?
solve?
Yeah.
The world's fastest man.
Yeah, that's it.
All right, this is a real quick one, easy. Write the expression as the sine, cosine, or tangent of an angle. All right, so the first thing I'm looking at is I have opposite things here. Actually, the first thing I'm looking at is I don't have a fraction. The tangent one is a fraction, so we know it's not tangent. All right? We know it's not cosine, because remember, cosine is cosine, cosine, and sine, sine. So it's got to be sine of something. All right, then the next thing I'm looking for is, remember in the formula for sine, the sign in the middle stayed the same. So this is definitely a subtraction. So this is sine 42 minus 17. And 42 minus 17 is sine 25. All right, sine 25. So that is, again, not that difficult. Just reason yourself through it. Don't overthink like that last guy did, right? All right. Next one, this is a little bit trickier. We want to find sine of x minus y given the following conditions. All right, so a couple of things. So we're saying this is in the third quadrant. Pi over 2, second quadrant. So negative 3, so I have a triangle that looks a little bit something like this. Negative 3 over 5 is cosine, right? And then we would know this would be 4, 3, 4, 5 triangle. All right. So then we have over here tangent of 8 over 15, and this is in the fourth quadrant. So this triangle would look a little bit something like this, right? Tangent y would be 8. Actually, that should be negative 8 over 15, right? So this would be a 8, 15, and 17 triangle. Okay, so we want to do this, so we're going to do the sine of this. So we do the sine of x, then the cosine of y. And then we're subtracting, so we're going to minus, we're going to switch it, the sine of y and the cosine of x. So we come down here, so there's the sine of x. So I go to my x triangle, this is my y. So I go to my x, the sine of x is 4 over 5. And the cosine of y is adjacent over hypotenuse. That's 15 over 17. All right. Minus the sine of y. So I go to my y, I go opposite over hypotenuse. So that's negative 8 over 17. And the cosine of x, that's negative 3 over 5. All right, so we have 60 over 85 minus a negative times a negative, so we have 24 over 85. All right. 60 minus 24, what's that give us? 36 over 85. All right. So again, it's very important that you set up these triangles, set them up correctly, and then just write it out. The fraction part shouldn't be that terrible. All right. It might be a little bit trickier with the tangent function. All right. So let's see how this guy finishes up on the Wheel of Fortune here.
C.
1C. Julia. Everything just follows.
Let's solve.
Go ahead.
On the spot dice spin.
No. Shelby?
On the spot decision.
Yeah, that's it. I don't think anyone has ever taken a more circuitous route to victory.
What blows my mind there is he had 3 of the worst guesses ever and still won that game. Like, how did that other girl not win? I have no idea. He still won that game, blew a chance at $1 million, blew a chance at a car, and still won. All right, luckiest guy ever, I guess. All right, we want to verify this. So we're doing our tangent difference formula. So I'm going to do the tangent of my first, which is x, minus the tangent of my second, which is pi. Then I do 1 minus, not minus, I was doing minus, so I do the opposite on the bottom, tangent x times tangent pi. All right, let's see, tangent x, we don't know what that is, it's a variable, but we know that tangent pi is 0, so tangent x minus 0, 1 plus, and again, we don't know tangent x, we know tangent pi is 0. I love 0, love it. You know why? Minus 0, it's just tangent x. Times 0, it's 0. 0 plus 1 is 1, and tangent x divided by 1 is tangent x. So we just showed that that is, in fact, an identity, that the tangent of x minus pi does, in fact, equal tangent of x. All right, that's a great little one to end on. All right, best of luck on your mastery check. I hope you do well, and I'll see you on the flip side.